Okay, starting a new chapter, starting chapter 2 after our test on chapter 1. Just a word of caution. Now you know what my tests are like. You know pretty much what is expected of you. Keep in mind what I said to you about chapter 1. Chapter 1 was a miserable chapter with an enormous amount of material. A lot of stuff you should have remembered from high school, and there were some new things that you've probably never seen before. But some of you will have to change your attitudes a bit as far as this horrible word called studying, all right? Studying is just a combination of the word student and dying. No, I really don't think so. But I do think that some of us will have to adjust our study techniques to do a better job on chapter 2. All right, so let's talk about chapter 2. And many of you will be glad to know that it's horribly different from chapter 1 in that it goes at a much slower pace, and I think it's a significantly easier chapter, probably one of the easiest chapters in the book. All right, so definition. And we're going to get quite a few definitions in chapter 2. That will be one thing you did not have in chapter 1. So a word to the wise here. When you're getting ready for a test on chapter 2, you're going to have to understand and be able to give me some definition. A function assigns to each x value in the domain a unique y value in the range. Okay? If you recall from chapter 1, we talked about the domain is what you're allowed to use for x. We didn't really say too much about the range, but now we're going to expand that. The domain is all the allowable or legal x values. The range is the y values that you get from using those x values. And notice, each x value must have a unique y value, one and only one. That's what the word unique means. Each x value can have only one y value. So for instance, here's a set of ordered pairs. 0 goes to 1. Do you see 0 going anywhere else than to 1? No. 2 goes to 3, pi goes to 5, 7 goes to 3. Each of the x values, 0, 1, 2, pi, and 7, go only one place. This is a function, okay? Compared with this, here you'll notice that 2 goes to 1 and 2 goes to 5. This is not a function, all right? It is a relation. I really don't have relation up there defined. A relation is just a group of ordered pairs. This is a relation as this is, but this one is a function, this one is not. Maybe some of you remember from your high school days, if 2 goes to 1, you go over 2 and up 1, and 2 goes to 5, you go over 2 and down 5. At the x value of 2, you're going 2 different places, and that function would fail a vertical line test. If you draw a vertical line and it hits the graph in 2 places or more, it is not a function. So for instance, if you look at this, okay, my word, if I draw a line here, it's going to hit twice. If I draw a line here, it's going to hit twice. If I draw a line right in here, it's going to hit twice. This is horribly, horribly, horribly not a function, okay? This one is a function. No matter where you draw a line, it only hits in one place. That means each x value only goes to one spot. Nowhere does it go to 2. This one, right, not a function because, boom, fails a vertical line test. This one, beautifully drawn, probably a cubic function with a degree of 3. You draw a line anywhere, it only hits the graph in one place, so it is a function. You should be able to tell me which are functions, which are not. Here's a different way of looking at functions. You have a domain and a range. You see 1 only goes here, 5 only goes here, 8 only goes here. Now I know some of you get all messed up with the fact that 1 and 8 both go to the same number. That's not a big deal. The definition says each x value can only go one place. Here, you've got a real problem. 1 is fine, but 5 goes to A, and 5 also goes to C. This one is not a function, whereas that one is. Okay, so how do we write functions? How do we read it? Right here is the way you write a function. This is red, this expression right here. F of x, f of x. That's the way you read that. F of x is x squared minus 4, right? F of x is simply a fancy way of saying the letter y, okay? I'll say it again. F of x is a fancy way of saying the letter y. Now, the neat thing about functional values, it does save you a little bit of time when you write functions, and we'll get to that in a second. Here I mentioned the domain is a set of x's, the range is a set of y values. The domain is a set of independent values. You can pick anything you want that's legal for x. The y depends upon what you pick for x. Like, for instance, if I pick 3 for x, I put 3 in for x. 9 minus 4 is 5. You only get 5 if you put 3 in for x, or I guess it would also work if you put negative 3 in for x, okay? But the y value is very much dependent upon what you put in for x. So the x is called the independent variable, and the y is the dependent variable. Now, notice this, the way you write this. Here we read this, g of x is 2x squared plus 7. If I want you to find g of 1, that is saying, find what this is equal to when g is 1. Much nicer to write. It's a nice shorthand way of writing that. Find what this is equal to when x is equal to 0, and so on out through here. So when you're finding g of 1, g of 1 is equal to 2 times 1 squared plus 7. Yeah? You just put the 1 in for the x's. 1 squared is 1 times 2 is 2. 2 plus 7 is 9. Okay? How about g of 0? G of 0 is 2 times 0 squared plus 7. 0 squared is 0 times anything is 0 plus 7 is 7. G of a minus 1. G of a minus 1 is 2 times a minus 1 squared plus 7. Okay? Now, we got a little bit of work to do. We have to square this out. Please excuse my dear Aunt Sally. We do exponents first. I got to take a minus 1 times a minus 1. Okay? Can you do that in your head? A minus 1 times a minus 1. A times a is a squared. So I have 2 times a squared. Your outers and your inners are negative 1a and negative 1a is negative 2a. And negative 1 times negative 1 is positive 1 plus 7. I squared it. Now take the 2 in. 2a squared minus 4a. 2 times 1 is 2 plus 7 is 9. Okay? All right. So, find x. So that g of x is 27. Find the x value. We're kind of doing it backwards. We know the answer is 27. So we know that 2x squared plus 7 is 27. We want to find x. Well, subtract 7. 2x squared is 20. You could have gotten everything on one side and tried to factor. You could have used the quadratic formula, but there's no x term. Remember, we talked about this. There's no x term. I can use square roots. Divide by 2. X squared is 10. So I know that x is the positive or the negative square root of 10. And you can give me a decimal for that if you like. Find x so that g of x is 0. We're doing the same thing again. We're just now setting this so that g of x is equal to 0. So subtract 7. 2x squared is negative 7. Divide by 2. X squared is negative 7 halves. And you can't take a square root of negative 7 halves. Okay? So this can never equal 0. Never. So there's no answer for when g of x is equal to 0. All right. Let h of x. Now, this is called a split function or a piecewise function. I wrote it this way just because in PowerPoint it's fairly tricky to write it the other way. The way this would be normally written, h of x is equal to, bracket, 2x minus 3 when x is bigger than 4, and x squared when x is less than 4. It's a two-part function called a split function or a piecewise function. All right? Find h of 3. H of 3. Well, where do I put the 3? Do I put it in here or here? Well, you only use this part when x is bigger than 4. You use this part when x is smaller than 4. So 3 is smaller. H of 3 should equal 9. How about h of negative 2? Negative 2 is once again smaller than 4, so you square negative 2, it's just 4. H of 5. 5 is bigger than 4. I have to put 5 up in here. 10 minus 3 is 7. How about the domain? What can I use for x's? Well, I can use x's that are bigger than 4, and I can use x's that are less than 4. I can use any real number whatsoever except 4. Okay, so the domain would be all real numbers except 4. And you can write it out like that. Find the x value so that h of x is 36. This is just like the one we did before. Okay, up here, we're going to do this problem backwards. If h of x is 36, now we don't know what x is. Okay, we don't know what x is. We've got to work it out for both parts. All right, so what about 2x minus 3? So if my final answer is 36, I know that 2x minus 3 must have equaled 36. Add 3, 2x is 39, or x is 18, 19 and a half. But hold it. X can't be 19 and a half here. Oh, yeah. Bigger than 4. Sure, 19 and a half. So if x is 19 and a half, 2 times 19 and a half is 39, minus 3 is 36. 19 and a half is one of the answers. Okay? What about down here? What about if x squared is 36? Isn't x equal to 6 or negative 6? But hold on, it can't be 6. It can only be negative 6. So the answer to the problem, there's two of them. 19 and a half will give us 36 in the first one. Negative 6 will give us 36 in the bottom. So either one of those will give us an answer of 36. Okay. Well, let's talk about more split functions. Okay, cell phone plan costs $39 a month with 400 free minutes, but if you use more minutes than 400, additional minutes cost 29 cents a minute, right, as a split function. So we want C of M. This is going to be a split function. The cost depends upon the number of minutes, okay? Now, unless you go over 400, all you're going to pay is $39 a month. So the cost would be $39 when M is less than or equal to 400. Are you with me? Okay, as long as you're 400 or smaller in minutes, it's just going to cost you $39. Okay, but if you go over 400, if M is greater than 400, let's talk about that. If M is greater than 400, not only do you have to pay the $39, but you have got to pay for those additional minutes. And you got to pay 29 cents. So we're going to pay 29 cents for additional minutes, which are ones over 40. You just can't put an M there. That's all your minutes, okay? What we want to find is how many additional minutes are there over 400. So you must take M minus 400. Now think about that. Like say you use 500 minutes in a month. you're going to have to pay more than 39 bucks. You're going to pay the 39, then you're going to pay 29 cents times your 100 extra minutes from 500 minus 400. Okay? Split function. Let's talk about finding domains. All right? Remember from chapter 1, the domain is what X can be legally. Now, where do you run into trouble? You can't have division by 0, and you can't take square roots of negatives. So you got to be really careful with problems that have division and roots. All right, so right here, I cannot divide by 0. Because I cannot divide by 0, X cannot be -4, huh? If X is -4, you're dividing by 0. So the answer to this problem, the domain would be all real numbers except for -4. Just write that out. All real numbers except -4. Now let's talk about that. You can't take square roots of negatives. You can't take square roots of negatives. Could X be -7? -7 plus 7, yeah, that's 0. Square root of 0 is 0. That's good. So -7 is okay. But what about -8? If X is -8, I'm in trouble. I'm trying to take the square root of a negative. Okay? What about anything just slightly more negative than -7, like -7.1? -7.1 plus 7 is still negative. You can't do it. Okay? So your domain in that one, -7 is like a boundary point. It can equal -7, but it can't go this way. It's got to go that way. Yeah? A little tricky. Now here, it's really tricky because you cannot divide by 0, although you can take the square root of 0, and you can't take square roots of negatives. Okay? So we can't have t being equal to 0, and we can't have it being negative. So the only thing t can be in this problem is positive. So t here must be bigger than 0. Real numbers bigger than 0. Okay? This one. All right, now we're going to have to be careful with this one. It's root t and then subtract 1. We can't have division by 0. So what can you not take the square root of? If you don't want a 0 on the bottom, t cannot be 1. If t is 1, you're in trouble. Okay, because you're going to be trying to divide by 0. How about if t is 0? Square root of 0. You can do that. 0 minus 1 is -1. 1 divided by -1. You can do that. Okay? So we can't have t equal to 1, and we can't take square roots of negatives. All right, so let's talk about this. T cannot equal 1. So here is 1. We know it can't be 1. Okay? Can the t values get bigger than 1? Like 2, 3, 4, 5? Can you take square roots of 2, 3, 4, 5? Sure. Can you subtract 1 and divide into 1? Sure. You might get ugly answers, but you can do it. So we know the domain would go up here. Okay? Can, here's 0, -1. Okay? Can we have t values to be fractions in here, like a half or a quarter or a tenth? Well, yeah, you can take square roots. You can take square roots of fractions, subtract 1. It's going to be ugly, but you can do it. Okay? Square roots and then -1 and divide. That's not a problem. All right? The only thing we can't do is take square roots of negatives. All right, so let's go down here. Where do we get into negatives? Square root, the minute we get past 0, 0 is acceptable. 0 is not a problem. Okay? So we can have 0 here as an answer. All these fractions are ugly, but they're okay. But the minute you get down here, you're trying to take square roots of negatives. Okay, and you can't do it. That's a tough one. right there. How about this one? No square roots, so we don't have to worry about square roots. But the bottom can't be 0. The bottom can't be 0. So what about x squared minus x equaling 0? Let's work it out. Pull an x out, factor. Set each part equal to 0. Don't I get 0 and 1? And my marker is failing me. So this problem, when we solve the bottom equal to 0, could be all real numbers except 0 and 1. All right? Let's look at this one. There's no square root, so we don't have to worry about square roots and negatives. We just can't get a 0 on the bottom. But wait a second. Absolute values. Aren't they always positive or 0? Right? We don't have to worry about this being a negative. So an absolute value plus 5 is always going to be 5 or bigger. All real numbers. Should work fine. How about the last one? That should be a small letter f. They should all be small letter f. So we have f of x is equal to x squared plus 5. F of x then is equal to x squared plus 5. F of minus 2. Put a minus 2 in here would be 4 plus 5 or 9. Plus 9 is x squared plus 14. Okay? There's homework. There is a cubic that we did in chapter 1. I just included an extra one so that you would not forget how to do cubics, and some problems on functions. And hopefully you're agreeing with me right now that yes, indeed, chapter 2 is far easier than chapter 1.